change some windows here so I can see all my stuff. Well, first of all, thank you all for letting us come and present at this partners meeting. I'm really excited, and I know that folks at Northwestern are really excited about this. So I'll just go ahead and jump in. There's a bit to cover, and I'll probably talk fast, and I apologize because I always do when I get nervous. But those of you that have seen me talk before know that. So real quick, I'm a team member of the repository and digital curation team at Northwestern. I'm the team lead of it. We do a lot of stuff that folks here generally do. And the repository software team I just want to call out is Adam Arling and Michael Klein, who's here with me in case there's a technical question that I can't answer cleanly. Brendan, myself, Karen, and Veronica, who is our new service owner. Oops. So back about a year and a half ago or so at a Samvera Connect, we posted this poster and talked a lot about our idea of changing our digital collections platform and viewing it more from a workflow standpoint rather than starting from a technology standpoint. And so that was about a year and a half ago. That was the real beginning of it, probably close to 2 years at this point. And it was really just a real raw idea in our head. And what we really wanted to do was to change and move away from this model where all of our items had to be fully ready to be described before getting into our preservation and repository system, which is where we had ended up. And so we would be digitizing works, and often they would sit on storage for months or years as our metadata specialists worked to describe them and worked very hard to describe them. But there, of course, was a bottleneck there because it takes time to describe objects, much longer than it does to digitize them. So our goal was to build a system that we could get items moved into the repository as quickly as possible, and then allow items to be fully described within the system and shareable from the system even before they're fully described. So where we ended up was with Meadow, and I'm going to just breeze through these slides real quick. We can come back to them if we need to. But the first goal was to be able to ingest assets really quickly via single work, or what we're calling an ingestion sheet that can deal with complex works, like works with multiple file sets per object. We also wanted to have pipelines that allowed addition of future steps. So one thing that we ended up realizing is that we kept having to add new steps to our pipeline, our processing pipeline, as assets change or assets type changed, or our needs internally changed. We also wanted to build in preservation auditing from the right away. So we didn't want it to be an afterthought. We wanted it to be the first thing that we thought about. And this last part is probably the most important part, I think, for this presentation here, is that we're using contemporary scaling techniques. So we built this from the ground up, knowing that we are going to be in a cloud environment. Our last crack at this, right, we built it on existing technology and then sort of applied some cloud computing techniques. This time we knew coming into the gate that we were going to use things like lambdas and be able to scale out very fast if need be. So where we ended up was being able to ingest around 5,000 2 gig TIFFs in complex works and build out these works in around 38 minutes is our current time. On our existing platform, that would have taken us overnight at least. So we would have set those off and let it go overnight. And now it takes a little less than an hour, or considerably less than an hour, I should say. The next step was on describing and editing works. And again, having watched our metadata folks work in our system, we realized that the real need that they had was to be able to bulk edit in large, do large bulk edits and massive updates. While we had nailed down one by one editing in kind of small batches, we realized more and more that they wanted to be able to batch edit whole collections or subgroups of collections, or sometimes multiple collections. And again, have that be real fast. In addition, they needed local authorities. We use a lot of authorities to drive our metadata, but inevitably we ran into problems where they're just, the terms we were looking for just didn't exist in the Library of Congress or FAST, for instance. And again, we wanted it to be really quick. So we were shooting for this kind of under half an hour for 5,000 works. And we got it down to around less than 10 minutes to batch edit up metadata on around 5,000 works. and publishing and sharing works. As we were moving forward, the goal was to be able to get works in as quickly as possible and then be able to turn around and get them out to our internal clients as quickly as possible, while also being able to mass publish works as need be. So that ability to share privately was driving a lot of this work. Some of these works may never end up in the public realm or available on our digital collection site. Some will, but it may take a long time for us to get rights secured or be able to actually describe them. That's sort of a key feature, and it's a really simple one. But to be able to share out an entire work, not just a file set, but an entire work with an end user researcher or many works. So what's a demo without a quick little architecture diagram? What we ended up with was building from scratch an Elixir app that manages the pipeline. Those of you not familiar with Elixir, it's a functional programming language, and it's really built with high concurrency in mind. And so we knew, again, from the ground up, that we wanted to be able to process information really quickly, and we needed a system that could handle that. So we tried a new programming language, and it worked out real well for us. The front end of digital collections is largely unchanged from our original crack at this a few years ago that we've presented on in the past. And that's in part because it's all API driven, right? So we have a front end sitting out in front that's talking to an API, and that API is loosely coupled to both the front end and back end. And in addition, we used a lot of lambdas. These little things here mean lambdas, and what lambdas are in AWS land, or they're called Google Cloud Functions in the Google world, are a small set of code that does exactly, you tend to write them so that they do one thing and one thing really well, and that's all that it does. But the real trick of it that we learned is that you can scale these things out. They're real small little bits of code that you can scale out to 1,000 concurrent jobs at once, right? So when you're talking about something like processing TIFFs, you could scale or try to scale vertically and have a really large machine be able to process that, like say 500 TIFFs at once, but it gets real hard real fast, and you run into real physical problems, right? So with cloud computing like this, you're able to process 500 2 gig TIFFs in seconds or in minutes, because there is no, everything is an independent process. So with that, we're gonna go ahead and jump into our demo. Are there any questions before I go ahead and jump into the demo? There probably will be after the demo, I'm sure. Go ahead and jump. All right. I have 2 environments here, so I changed the background color on them so that I make sure I don't accidentally change our production environment. I'm going to give you a quick breeze through the front end of Meadow, which again is largely for internal users. Digital collections, which some of you have seen before or we've talked about, is our front end for end users, for our researchers and others using our system directly. So what you have in Meadow is you're presented, once you log in, with a big search and describe works button and some stats right up top. One of the things we did is we wanted to draw the connection very clearly in our internal users' minds between what's happening on Meadow and the work that's going into our digital collections platform and the fact that users are using it. So we spent some time integrating Google Analytics reports directly into the system. So there's sort of a heads up display as well as a more formal display. Sometimes this takes a little while if I'm on Zoom because it takes all the bandwidth up. But so any end user within the system now can immediately go and get reports and statistics right on our digital collection, right on Meadow, without having to ask around for reports and reporting. And these are all filterable by the collections that our curators care about most. And I know I have limited time, so I know I'm going real quick, but and then some other areas that look real familiar to everybody is, of course, recently updated collections, as well as things like work visibility. A lot of the language here is lifted directly from Hyrax. So within a collection, one can describe it, one can see it, and one can see an individual work. And then an individual work, of course, has lots of metadata, and I managed to pick one without any metadata yet. So we're going to go over to staging, and I'm going to show you how we get works in here and exactly how all that works out here. So the first thing we're going to do is we're going to go here, and this is a project-based system. So we have a production staff that that regularly is digitizing our works and adding them to the system. So they create projects, and then projects are organized into ingest sheets. And ingest sheets are a really simple spreadsheet that has bare minimum metadata, largely where the file is, what a description of the file set is, and then this work accession number, which allows grouping into complex works like multi-file set works. And so when one drops one of those off, you grab the right spreadsheet so we don't get any errors. You'll see that it validates really quickly what happened here. This is around 100 file sets organized into 50 works. And so what's happening here is that it goes and checks to make sure that all of the existing, all of the TIFFs that are referenced were there, and that happened really quick. So we do a quick little pre-flight check. And then what's happening now is that it's creating pyramidal TIFFs, creating works. It's moving those works moving the file sets over to a preservation bucket. And then it's performing some it's also creating checksums for every single file that came in. And actually 2 types of checksums, both a SHA-1 and a SHA-256. And ultimately attaching all those file sets back up to those works that were created. And in another second here, we'll see it. One of the other nice things about this system is that I can navigate around, as it were, and come back without having to sort of wait for all this to happen. But I still get live feedback about what the state of the actual ingest is. You can also see that we have these nice little ingest in progress buttons. Oh, this is that moment where it gets hung at 98% because I'm doing a live demo, isn't it? I'm going to come back to that 1 second because inevitably live demos always hang slightly longer than you expect them to. Actually, I'll go ahead and get in and we'll show some batch editing, if that sounds good. So the next step in the process, I'm not quite sure why that hung like that. The next step in the process is batch editing, which we've taken some care. The large, sorry, I'm talking too quick. The interface is all completely search driven. And what that means is that there's really only one thing for anybody to learn. So there's only one place for them to come through it. So if anybody's doing anything, they're doing it via a search and facet. And in here, what I'm looking at is a single ingest sheet. And I'm going to go ahead and select all of those works. And we're going to start with a batch edit. What you end up with on a batch edit here is this nice little preview of items that you are editing. And what this allows is mass applying works or batch applying metadata at the work level to all the items that you've to all of the works that you've chosen in that previous search. It's very hard for sometimes to type and talk at the same time during a live demo, I'm realizing. And these are all, again, authority driven. We wrote a small authority tool called Authoritex as well, which is part of this and is out there in the world for anybody to use. I'll do a local authority there, and we'll go ahead and save items. You'll see that on the batch edit, what we end up with is an adding and a replacing, and then the ability to add a nickname. This is sort of like a commit so that you can come back later. I'm not going to add an apostrophe actually. And a real quick, I understand, to make sure that they understand this is in the real world and it's committing them. You'll see it goes from queued to complete fairly quickly. Although I'm a little worried something else is happening here. This usually happens in seconds. There it goes. I think I must be eating up.
It's just that the process that checks for waiting batches has a delay time to it. So
yeah,
if you hit it right before the check, it goes immediately. If you hit it right after the check, you have to wait for the next cycle.
And I'm doing a live demo, which means, of course, my nerves are up, which makes time expand, right? Or shrink. So some of the nice stuff that happened, or some of the stuff that happened behind the scenes there, is that all of our batch edits, whether it's 50 items or 5,000 items, or we've run batches on 50,000 items, they're based on searches, and we record the search that was executed in order to perform that batch update. So that's what you're looking at here. This ends up being like a ticker tape for our metadata specialists. But as you can, all the way down to the Elasticsearch query itself, if we need to try to recreate it, both for troubleshooting as well as just for record keeping, it shows what was added and what was replaced. And these are change sets that were actually executed by the move. But as one might expect, because this is search-based, I might perform a batch that makes my search become irrelevant. And that was one of the sort of designy things we had to get around. So what we've done now is that we add an ID to every batch update so that an end user can come back and get at the works that they changed. And this is both to undo a problem if there was a problem created, as well as just to be able to continue working on that same batch. So as you can see, it's got a unique ID at that level. One of the other key nice features here is that there's round tripping of metadata at the spreadsheet level. And so I just kicked off a quick download. I'm not going to go through this process, but I'll at least show you what those spreadsheets look like. Again, it's search-based, so it tells me the search that was executed, an ID for each work, as well as all the metadata that I can update at the work level, including controlled vocabularies and vocabularies that are based on, controlled items. Sorry, oops, where did I lose that? All right, and the final couple of things I was going to show you here is our preservation checks from within. Actually, I'm going to show you in two places. The first one is, so we went through a little bit about descriptive metadata, administrative metadata. Again, this is a lot of material that folks here are familiar with. You can see, of course, it records how it came in, whether through the ingest project and ingest sheet that it came in through. Our structure, and this is where we manage multi-file works, and the structure tab itself essentially generates our IIIF manifest. And then our preservation tab, and this shows, in this case, see there's two different file sets here, although only one is shown in the viewer. That's because we have a special file type here called preservation that only goes through the preservation pipeline, not the derivative generation pipeline. And so that file set is not part of the IIIF manifest. It's in fact redundant with the one above it. It's just it's a preservation copy of the file set above it. But at the work level itself, you see this little verified button. What this shows is that it went through our preservation pipeline. As I hit this, it verifies it's in the S3 bucket where we expect it to be, in the preservation bucket where we expect it to be. And it also allows you to copy the 256 SHA-256 checksum or the path to the bucket itself from right from this preservation thing if you need to go find originals. And then, of course, there's technical metadata associated with each of those. There's one more big feature I'm going to show, and then I'm going to stop talking for a little bit. Or two big features, I suppose. Actually, let me go back to that. This get shareable link, I think I spoke about briefly, kicks off a link, a privately shared link over to digital collections. For this, again, is for end users. So if we have a private work or a work that hasn't been fully described and published that we need to share with researchers, this is how one would do that. The unique thing about it is it can share multi-page works. Of course, I accidentally picked one that was only a single page. But whether that's a book or manuscript, we could also share that out without having to do them one at a time. And they're self-expiring links. And now I'm going to show you the last big feature, and I'm going to show you one with errors on purpose, is our preservation checks. So this one has some errors going on, and that's kind of on purpose. This is on our staging environment. Nightly, what happens is, oh, and I did not preload. Let me download one of these. Nightly, we run a job that that runs through every file set, every preservation file set and derivatives on the system, and checks to make sure that they're there, verifies some basic information about them, and then presents a report. And this is for auditing purposes. So one thing, the errors can be as simple as a derivative isn't there or isn't where we expect it to be. Another one might be that the preservation file isn't where we expect it to be. This is in staging, so we knew that there was going to be some errors. And this gives both my developers as well as the team as a whole at Northwestern confidence that things are where they expect them to be, and we can remediate them quickly when they aren't there. If I have a second, I can try to load this into Google so y'all can see it real quick. 1 second. That's going to take a little bit. That's going to take a little bit, so I don't want to make everybody watch a thing go up. So I'm going to generally stop my presentation here, and I can come back to that if folks are interested in seeing that. If there's, oh, there it is. So I'll go back to it right now. Sorry, I forgot to load this one. I'm going to go ahead and stop presentation now while this is loading. We can come back to that if we want to, but I'll stop and ask if there's any questions.
Hi, David. I typed a question in the chat, but
oh, did you? I'm not seeing. Sorry, I'm not seeing the chat for some reason. Go ahead.
I was just well, it got spell corrected to retractable. Are the shared items restrictable by anything besides the obscurity of the link?
No, not currently. Our first set of features is just the obscurity of the link, and then it self-destructs. So you create one, and it creates a unique one each time, and that obscure link then self-destructs after 2 weeks. Let me go to the chat. So for some reason, I lost my chat window. Not sure if I have to stop sharing to see chat.
David, do you have any sense of the running cost of all of the Lambdas and the Elasticsearch instance and all those parts?
Yeah, it's way cheaper than we would have ever expected. I'm happy to share or show that, even time allowing. So one of the great things about I'm not sure I'm going to be able to log in quick enough. About stuff in a cloud environment that I found is that it's way easier to control costs. So the instance running Meadow itself, which has around a couple 100,000 works in it, or file sets now, is about $30 a month to run just the instance that's running Meadow, because it can be very small, right? Like we don't need a large one because we're not doing a whole lot with it. And the Lambdas themselves, let me see even if anybody's run any through here. If folks are interested in this. So within CloudWatch, right, we can get all sorts of metrics on it and everything. Generally, it costs like less than $1 to run 10,000 items through in Lambdas. I mean, it's insignificant. And again, like the cool thing is that, let me find it, is that with a little bit of, oh, I'm sorry, I'm not sharing anymore. Let me share this screen. is that you're able to write reports, right? That essentially tell you exactly what you're doing on every Lambda. And it shows total costs here. So this is the last 3 hours, and it looks like we've spent 60 cents in the last 3 hours, and it's Monday. So I imagine someone drove through the 60-cent part, and that's our IIIF server. So that also is powering digital collections and Meadow at the same time. So that's the 60-cent part, and that one is a slightly bigger Lambda than the others. But just to process the works in this morning, which is often a busy time, is hey pennies. And I finally have a use for my favorite word, which is hey penny.
Awesome, thank you.
Yeah. And I'm happy to share, if anybody's doing that kind of work with Lambdas or is curious about it, I'm happy to do a talk through that with anybody, of course, and partners on that stuff. We've had to learn a lot as we went. How many full-time? Yeah, we completed this whole project. We could, that's a really great question. In all honesty, so the whole project was about 1.5 years, and some of these Lambdas, at least 3 of them, Michael, correct if I'm wrong, we weren't planning on using until we ran into some, in particular, like the digester, like the generation of SHA-256 checksums. We weren't planning on even going that road because we thought we could do it on the Meadow box itself. But once we really scaled it and pushed it, we just ran into bottlenecks, and we rewrote those in less than a sprint. I want to say it was half a sprint for at least two of the bigger ones that have saved us a ton of time and money, because our approach would have been to scale out the Meadow boxes itself, which would have been considerably more expensive. I think in part, if the idea that it does just one thing, once you wrap your head around that and you can figure out a part to break off that's costing you money, then it's considerably easier to kind of reason about, if that makes sense. You're not writing a whole program, you're just writing a little part of it.
David, that all looks really fantastic. I guess one of the questions I have is, can you talk a little bit about your digitization to upload pipeline? Like, do you do a lot of in-house digitization versus vendor, and how do the files get to S3 or wherever? Sure.
Yeah, we do both. I mean, so a lot of our stuff is vendored out. Our works that can't be vendored out because they're super rare. Those are done in-house. And so that they come back from a vendor, there's a quick QC from our production team. Actually, I shouldn't say quick. There's a QC from our production team, at which point they then use commodity tools like CyberDuck is what we're using because it's real fast, and upload materials from our local instances up to S3. And the goal is once they're in that S3 bucket, right away they run that ingest sheet so that it gets into the preservation system. Where again, like in the past, they sort of sat there until we were able to describe them and organize them and then uploaded them into a repository. So it's sort of the goal was to kind of flip that around a little bit.
Great, thanks. Yeah, we recently switched to using an SFTP upload client. I think it's called Truck.
Oh, cool.
But I know we looked at CyberDuck too.
Yeah, so yeah, CyberDuck's been good to us. We've tried a couple different ones and people just seemed familiar with it. So it was pretty straightforward for them to learn it. All right. Thanks everyone. And again, we're always around there. The team will be doing some presentations at Virtual Connect on this stuff as well. And then we're always around. Thank you.